Hi, and welcome to the haunted wasteland of the advent of code. It's day 8, actually. Okay, let's read the task. You're still riding a camel across desert island when you spot a sandstorm quickly approaching. Okay. I have a pouch of maps. Maybe. At least you're pretty sure that's what they are. Okay. So one of the document contains a list of left-right instructions, and the rest seems to describe some kind of network of labeled nodes. Ooh, I smell graphs in here. It seems like you're meant to use the left-right instructions to navigate the network. Good. Perhaps. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the instructions until you reach ZZZ. Okay, this format defines each node of the network individually. For example, is this right left? And then I have the nodes. Oh, so my guess is that at AA you can go left to BBB and right to CCC. At BBB you can go left to DDD and right to EEE. And so on until you have this loop. But you can also have a loop here, and it's some kind of an impasse. Okay, and this is a kind of an impasse. Okay, starting with AAA, you need to look up the next element based on the next left-right instructions to your input. In this example, start with AAA and go right by choosing the right element, which is CCC. Yeah. Then L means to choose the left element of CCC. Yeah, that's correct. By following, you reach that in 2 steps. Of course, you might not find that right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. Good. It takes 6 steps to reach that. Okay, starting, how many steps are required to reach that? Follow the left-right instructions. How many steps are required to reach that? So I have a graph. It can contain loops. I am given a pattern which defines a chunk of the path in this graph. Okay. How many steps are required to reach that? So let's take a look at the input. How big is it? Well, it's pretty big. But I hope it's not prohibitively big. Okay, let's start. Let's save this into day 8. Okay, and let's save the example. Example 2. And let's save the first one to example 1. Okay. Now let's do Cabal init. Let's do stack init. Let's do stack run. Well, I feel like I will regret choosing Haskell for this task, because traversing the graphs is not exactly easy. many steps are required to reach that? First of all, in any case, I have to parse this. And this does not map straightforwardly into something Haskell again. But okay, yeah, that's not a big deal. Yeah, just as usual, fpath, environment, get args, then input is parsed from read file fpath, then let's print how many steps. Solve one input. Yeah, let's just write this, spell this out, and this will produce a list of booleans, I believe, for the instructions where to go, and the second structure will be something which can be more complicated. And this is actually a good time to think, how do I represent the graph here? Take the list of the instructions and then take something and I produce an integer. So this is directions. Okay, let's call it directions and graph. Okay, let's think how to represent this well. So first of all, this should be a read-only structure. It should be reasonably efficient. Actually, why not map this again? Yep, lots of nodes. So, what could be the graph be? Would it be like this? Type string from node into a pair of other nodes. And then I just use it here and I use it here. The first thing that I can do is to just follow it naively. Is this a thin enough representation for the graph? So do I bake any assumptions about it in here? Here I don't, and for the graph, okay, let's assume it's reasonably thin, so I don't make any wrong assumptions here. Okay, let's parse. So first of all, the first line is the instructions, and the rest is for the graph. Okay. So let's say that are directions always in one line? Oh, stop. Well, they are. Then an empty line, and then graph lines. And I say that input decomposes into that. Sounds good. Then how do I produce directions? And the graph. So let's say the graph is undefined for now, and let's say the directions are. I have to map each character with lookup in from list of character L corresponds to false and character R corresponds to right. Equal to true. Yeah. And I just map the dir str. And let's even say that I look it up unconditionally. I don't care about any other symbol. It should be pass error if there are any other symbols in this string. So, what's wrong with you? Take DHCI, map, data map as M. Is this not how you look it up? Oh, I should add containers in here. Build depends on containers as well. Okay, let's restart. Let's import map. So how do you look up unconditionally? Oh, okay, I just need the parentheses. Yeah, now it works. Okay, good. Yep. Actually, I didn't even need the lists. Yeah, what I could just do is list L lookup, and it takes an element. Okay. Yeah, I didn't need the map for that. Yeah, and this is the lines of the input. Yep. Yeah, now it type checks, or does it? Oh yes. It's not lookup. It's just wait. Do I have an unconditional lookup? Yeah, I think this is this thing. And the list also needs to be in the scope. What's wrong? It's a string. It takes a character. Oh, yes. I need to look up this way. Yeah. With why is it expected to be a list of ints? Is it not character to you? Well, oh right. It's a lookup by index. Okay, yeah, that's true. Okay, let's just write it as a programmer would do. Lookup, see in this then variable not in scope. Yeah. Data maybe, and from what env is not defined. Oh, yes, I agree. Right, and as env. One mode is loaded. One module is loaded. So okay, it's possible to do. Okay. So how do I parse the graph? I should construct given graph lines from list, and list is composed as parse node, map parse node, graph lines, where parse node takes a line, it takes a string and produces node and a couple of other nodes. Let's say that yeah, let's say yeah, I wish I had a GURPS here. On the other hand, white spaces do not matter here in this format, so let's just drop C is space from the line. Okay, then I can split by that do not satisfy. Okay. Okay, I really need the subware. So let's call this like this. Then I need to split it into what? Into the node name and a character for the equals and children, and this is equal to break at is equal to equal. Interesting, yeah. Actually, let's reduce this immediately. Now, so this a node and children. Okay, now let's parse the second line. So strip prefix like this from just and let's strip suffix. Do I not have else strip suffix? Only strip prefix. Yeah. Okay. Okay, let's just say that this is the init of the line, and this must be split by is equal to the comma, and then this produces child1 comma child2, defined but not used. Okay, could not match the expected type int. Why? Oh, yeah, just filter. Not is space. Yeah. Defined but not used. So it seems to type check, and let's say that this is child1, child2. Parse input on where. Okay. It's not a problem. Reload. So 1. What's the problem with it? Did I forget any parentheses anywhere? Yeah, that's true. One module is loaded. Let's parse it file example1.txt. So the instructions are right, left, and the map is from AA to B, B and CC, from B to D and E, from C to Z and G, from D to D to G, from E. Okay. Now, how many steps are required to reach that? The parsing is done. countSteps. Given a graph and given the list of let's call it directions, the list of booleans, what do? Given the graph and given the directions, I have to produce a number of steps. I also need some constants like start node is equal to AAA type string, and end node is equal to z of type string. Okay, now let's count the steps. So I have a graph, I have directions, undefined. What do I need to do? At each step, so I start with the start node. At each step I have a node where next node, next. It takes node to node and take it your where did I define directions? Let's say it like this, and now this becomes the list of directions, and this becomes I have a direction, and it maps a node into node. So dir. So case dir of that looks more natural. Let's say case false. I take the right node, the left node. Okay. Node. So what do? I have my graph. I can look up children by the node. Given the children, left, right, I can choose. Whatever. So do I not have content here? Is it called bool? Oh, right. Okay. So I can choose either left or right. 1, 2, 3. The second one is 2. I can choose either left or right depending on the direction. What's wrong with you? Okay, yeah. Parse error. What do you need? Oh, right. Yeah. It's an infix operator, yeah. Haskell, why do I need to import this stuff? Okay, that's right. Left, right. Okay. countSteps of directions, and this becomes the list of direction. Okay, this takes a graph and a list of directions. And let's say that count1 is equal to countSteps using the graph, using the directions, and oh, yes, that's only a part of the solution. So what happens next? I remember there was a thing called iterate. So it takes a function of this that takes a value and produces another value. It takes the initial value and it unfolds it. Basically, I could say that length of iterate by next and starting from start node. Take while is not equal to the end node. And that should be it, right? And directions. What happens to directions? I also need to supply... Oh, it seemed natural at the time, but yeah, now I need to swap the arguments. Okay, yeah, not equal is written like this. Iterate next with interesting. This actually looks like fold over an indefinite sequence. Can I do that? Take 10, sum. So it starts with some state, takes a sequence and produces another sequence. Actually, scanl makes more sense. I just don't know if it can do that with the repeated. So yeah, let's try to do that. Scanl. Let's say plus. It's just a test at this point. Repeat 1 and let's take 5. Too few arguments because I do need as the starting state here. Okay, yeah, that sounds good. Okay. Why does it start with 0? Why do I care? Okay. Take while is not equal to end node. And I have to produce the next over the list of the directions. There's a cycle. Is there such a thing? Cycle. Yeah, it is. So if I say take 3 cycle ABC, that just repeats it. Okay, I'll cycle. Yeah, that's correct. And then I scanl over this indefinite list, and then I take while it's not equal to the end node, and I take the length. Well, actually this is a useful helper on its own. Okay, and let's say that follow is equal to this, and and follow is what? Scanl next start node cycle follow directions. And that should produce the path, which is useful to be able to see to debug. So it takes a list of directions and produces a list of nodes, which is the path. Okay, where is not needed anymore. Length of followDirections in, but I also need the graph. Wait. Oh, yeah. So it really needs the graph as well. And here it needs to capture the graph. And here it needs the graph. And here I need to say that it needs to follow the graph. And it needs to follow the directions. What's on here? Cannot match type with okay. Oh, it looks like I messed up the order of arguments somewhere. So it takes a start node, which is a so B is a string. This one is a list of characters. So I take a string, which is a node. Ah, yes. Yes. Here I need to switch it back again. There, and yeah. Okay. Let's try to follow a list of directions. So let's say that I have directions and the graph taken parsed from read file example 1 txt. Let's look at the directions and let's look at the graph. Looks sensible. Let's follow directions in the graph. And it really needs, yeah, it's the wrong order. AAC. So I have to do how many steps? Did Wasteland 2 steps. Okay, in this case have to do 6 steps. Let's parse again. Example 2, dears, and graph now looks like this. And if I follow the directions, I have 6 steps, and length is 6. Now reload and sample 1 txt, sample 2 txt, and input. I hope this will be efficient enough. Okay. That's the right answer. Okay, let's proceed. Now the hard part, part 2. The sandstorm is upon you and you aren't any closer, okay? But you barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? The number of nodes with names ending in A is equal to the number ending in Z. And if you were a ghost, you'd probably just start at every node that ends with A and follow out the path at the same time until they all simultaneously end up at nodes that end with that. For example, simultaneously navigate away until all of the nodes that you're currently on end with that. So you are at 11A and 22A. Okay, you choose all of the left paths, and that means this one and this one. Then you choose all of the right paths, and that means this one and where was I? And this one. Okay. You end up entirely on nodes that end in Z after 6 steps. How many steps does it take before you're only on nodes that end with Z? Okay, why not? So, let's just think quickly. The example sounds pretty easy. So, example, let's this be a regular example. But what I'm interested in, how many nodes do I need to iterate at once? Basically, the answer to this question is how many nodes end with A in their name. Let's do just that. Let's grab from the start A in the input txt. That's it. Only 6 nodes. How many nodes end with that? Okay, that's it. Only 6 nodes. Okay, why not brute force it? Okay, let's do it. So there is a second part. Solve 2. Take a list of directions. It takes a graph and it outputs an int. Solve 2. Take directions, graph, and it's equal to undefined for now. Okay, how do I iterate? Was it loaded? Yeah, that's correct. So I actually need to filter out the start nodes, and these are filter with m keys, and then I can just filter by last is equal to A. Yeah, that's not how we do it. Okay, yeah, and it needs to be applied to graph. Yeah, let's parse again. And let's parse the example, and let's try to see if it works. Yeah, and it produces the list of 2 nodes. Okay, start nodes is equal to filter node last character of the node is equal to A, and I look at the keys of the graph. Okay, defined but not used. Start nodes. Okay, then I need to iterate on multiple next nodes. So what changes? I still have my graph as the context. I take a list of nodes at this point, and I take a direction again, and I produce a list of nodes. Next nodes. It takes a graph, it takes nodes, it takes a direction, and it's undefined for now. How did I do it previously? Okay, can I just map next graph over nodes, node, next graph, node direction. Is that it? One module is loaded. Let's parse. Let's say start nodes is equal to filter by last n is equal to a of what of m keys of the graph. Start nodes are these ones, and what happens when I ask next nodes? Graph start nodes direction. Let's say it's false. Okay, do I get the right why do we go? Oh, right. Yes. And then okay, can I just iterate on that? What did I do in sol1? countSteps. Okay. I could actually make it generic. Okay, let's say that follow directions. It has a graph as a context. It has a list of directions. It has a list of starting nodes, and it produces a list of nodes, which can be very long. So I take the graph, I take the directions, and I take the nodes, which are the starting nodes. Start. Okay, and then I say that this is basically I need to cycle the directions. Then for each one I do scanl next nodes. What's the type of the next nodes? So it must take a graph. It must take nodes, and it produces the next nodes. Okay, scanl, and is that it? Okay, that is sensible. Let's reload. Where? Some bogus where? Oh, okay, here, yeah. Take while all and all finish. And maybe it's easier to spell this. Given a list of nodes, I check that all node last n is equal to that for nodes. And this can be actually written like this. Yeah, take while follow directions in a graph using the directions with start nodes. And then I take the length of this. Is that it? Good match type boolean. Why? It's a direction. It's a list of nodes. Sounds right. Oh yes. Start. Takes from the start. Now what? So what is the type of scanner? It takes a function, the start state. Oh, I see. Yeah, dir comes from here. Yeah. Where was it coming from? Okay. One module is loaded. So what can I do now? Can I parse again? And can I say follow directions? And since I know the answer, it should be at least 10. Follow directions in the graph using the given directions. Okay, I just know the nodes. These are 11A and 22A. I think so, yeah. So the first step we are here, and the next step we are at 11B and 22B. Next step goes to 11Z and 22C. Then it goes to 11B and 22Z, 11Z and 22B, 11B and 22C. And at this steps it should end. So now if I ask take while all the node name, and the last character in the node name is Z. Oh, it's take while it's not equal. It's not. And the length of this thing is 6. Okay. I think that should solve it. Main example txt produces 6. And yeah, let's run it in by stack run, because it will be native code and it will be much more efficient. Okay. Now I'm wondering what is happening. Will brute force work? Oh yeah, actually it might not. So I'm back. It's been brute forcing for a while, and yeah, it can take a really long time to actually visit all of the nodes in a dumb way. So I thought about this task, and the idea is I want to remember the visited nodes, and I want to know if I visit a node the second time, and I want to know how many time it takes, how many steps it takes to to cycle in the same node in one path again. And at this point, this is just an exploratory thing, so I don't have this as a part of the solution. So let's follow the directions, but with a twist. I want to accumulate the number of the visited nodes and the number of times that I visited them. So that really starts to look complicated. But fortunately, I do have my state here. Okay. What can I do? I can say that for each start node, I also add another piece of state. I add an empty map. And yeah, I do want tuple sections in here. Yeah, I don't know why are they not turned on by default. Tuple sections. Okay, and then here when I get my state visited, I have the map of visited nodes, and that's what I actually produce. Map from node to int. Additionally, okay. What now? And I have to take this, and I have to okay, that starts getting unwieldy. So let's say where let's say this is go, and it takes all the visited, yeah, and it's something like this. Let's say that I scan all with go. Let's state that the initial state is equal to map empty start nodes. Let's replace this with initial. Go takes a direction. Okay. nextNodes using the graph and using the nodes and using the direction, and it produces a new visited. Okay. Let's say that let nodes is equal to nextNodes in nodes visited. Now visited. I can map the visited maps, and for each one so yeah, one thing that I was not talking about is my assumption that when you have a path that eventually converges to a Z node, then during one cycle of directions, you have to visit this Z node. Otherwise, it's not possible to pass it at all. Interesting. Okay, let's just map it for now. What is the best way to do that? Insert. Nope. Update. Nope. Adjust. It must exist already. That's not what I want. Is my only option alter? Yeah, I think so. So just malter. Oh, okay, yeah. Malter with by key, which is that gives me a node and visit map, and then I alter the visit map using the node as the key, and in here I receive something. Which was the previous number of time and visit, maybe non-visit. Let's just call that key, and I have to produce not key, the number of visits, and I have to produce just successor of from maybe 0. Yeah, and that should give me the list of visited nodes. Node type variable. What? Okay. And then at each step I can trace it. The syntax is again not right somewhere. So it's line 61. Where? Good. What is on here again? 51. Oh, yes. What's one now? Initial. Okay. What's one now? 55. Check and insert type. No, I did not. Non-type variable argument in the constraint. What? What did I do wrong? Ooh, yeah, I see it now. Oh, I see it now, yeah. So the nodes has a type node. Well, but it shouldn't. Yeah, that's correct. Okay. I see now, yeah. And visit map. Which not type variable argument? Okay, something is still wrong. At least I know what. Why cannot you infer this? Show. It's a list of node and a map from node to int. No, I did not. Oh, okay. Ah. StartNodes in the graph. What's one now? Ah, I see. Yeah, one is the first node. Okay, what's one now? The directions. Cool. I take list of a node and int. I take a direction and produce the same. What's one now? Because mesh type y. Well, now it's better. What's on here? And it produces a node. Didn't again. So let's visit. You have a direction. Let's just say that map visit with this direction. Visit what nodes? And I say that for a node and a visit map, this is equal to that nodes is equal to nextNodes. It takes a graph. Well, yeah, it's really just this next graph, and next takes what? Graph, node, and the direction. Visit map is equal to alter visit map with maybe num and it returns a just next number of from maybe 0 over mbinum. Or I can shorten this to in node visit map this. Okay, that's it. Type check no. What type is visit map? No. What type is visit map? What's on with you? Oh, alter by key, and the key is node. Okay. Follow. Something is still on here. I want to produce to see the path that it takes. Then, so the problem is in line 72. Why? followDirections produces a list of nodes and the map of visited node. For each one, oh, map FSD, yeah. Okay. Now what? What I want to see is follow. So let's parse the graph. Let's parse. And now I take the input txt as a whole. So this is huge now. That's okay. The graph is also huge now. But what I can do, I can say that follow directions in the graph, and I want to take one follow directions in the graph. Take the directions. I take the startNodes of the graph, and I take one. So AAA, the LA. These are the 6 starting nodes, and for each and I want to see 100 iterations for this then. Oh, no, I actually don't want to see the visited map. So I have the node, I have the visit map, and I can of what? First of all, I can show the visited plus top plus filter with key, and this must be shown. Yep. So what I want to see, given some node and given the number of visits in it, given. Step. That's good. Do we have any of that in here? Nope. Okay, let's increase that. Do I have any Z in there? Still no. Interesting. Does it come across any Z? No, in 1000 steps. That's bad. Let's look again. And here it starts. So, is there any of that? Still no. Mm-hmm. Mm-hmm. Oh, yes, print nodes. Nothing. Just like that. Oh, now we're talking. Okay, yeah. So let's zip it with like this. Let's have the index here, and I want to print I nodes. What's on here? Yeah. So at the step 12,361, the fifth start node comes to a possible end. At the step 13,939, the fourth node comes to a possible end. At the step 24,722, the fifth node again comes to NTZ, and in 12,361 step again, it again comes to NTZ. So it just cycles through them. And this is good. When does the first node come to an end? In 15,517 steps, and in 31,033 steps it comes to that again, and again, and again. Okay. What's the cycle for the second path? XBZ, so it's 20,777, and for this, yeah, so I could ask the question, how many cycles does it take for each of the nodes to come to an ending position? Let's do that. Actually, I didn't need this follow direction thing at all. Wow. So, basically, all that I needed was I have the start nodes in the graph. Then, for each, I determine the cycle. I determine how many steps does it take for it to come to an end. Steps, map, count steps, start. I can even do that here right now. Oh, count steps. Yeah, count steps might need some additional information. What's the type of the count steps? It takes a graph and a list of directions. Again, what's on? Start nodes. Start nodes. No information is available. Why? Find. So startNodes takes a graph and produces a list of nodes. Steps. What's the type of countSteps? It takes a list of directions and oh, it takes a graph. Yeah, obviously. Yeah. Now what? Steps. Map. Okay, what do you miss now? Oh, countSteps. Okay. It doesn't need starting node. It tries to determine it itself. Follow. What does follow do? Okay, it's just being too smart, I would say. So let's make it explicit. So we start with the start node, and the start node goes here, and here I also need the start node, and this is a start node from node, or rather start. Yeah. Now what's broken? countSteps starting from start node. Is it unbroken? Okay. One module is loaded. Okay, that's good. Okay. Yeah, so let's parse again. Let's oh right, countSteps has their own termination condition. Okay. Follow countSteps. Steps. Again, follow takes too much logic. And okay, and countSteps must now take the end node. Okay. What's on? Oh yeah. Let's parse again. Let's try it. Okay. Start. Yeah. And it really needs to be a callback. Is end. Is end. And this really needs to be not is end. Let's reload. And node is equal to end node. Let's reload. Up steps. Variable not in scope graph. Why? Is it in graph? In which scope? Is end? No. Line 28. No, it's the interactive line. Okay. Yeah. I need to parse. Yeah. No instance. Okay, that's good. Start and oh, let's just do the helper is and node. Is and node. So it takes a node and it checks if the last character of the node is equal to z. Okay. Is and node. Let's reload. Let's reparse and let's map. And that basically gives the cycles that we have. And the product of these cycles should give the answer. Product. Yikes. That's a huge number. That's not the right answer. It's too high. Yeah. Oh, do I need to find the GCD? Yeah, I think I should find the GCD for it. Yeah. Folder 1, GCD. It's list folder 1. Folder 1, yeah. What? That's really not correct. What's the opposite of GCD? Is it LCM, common multiplier? 12 and 15? Oh, sounds right, yeah. So this is LCM. And yeah, that looks in line with the results. Turn to the 8 and submit. That's the right answer. Yeah. Yeah, let's just put it in the code. So the solution is let's folder 1 using the least common multiplier. Least common multiple, that's what it's called. Okay, and then of what? Yeah, let's just write this down and be done with it. Count steps in the graph. There's start is and node applied to the list of starting nodes in the graph. Yeah. Does it produce the right answer? Example 6. Yep. Input. Yep. Okay, we're done here.